Surface area of a hollow tube. Well, not completely hollow. One end is sealed off and it has a thickness. Let me show you what I mean. Shift add. Nope. Here we go. A cylinder. There's a cylinder. You see it has a top, side, and it has a bottom. It's like a solid bar at the moment. I'll go into edit mode. Surface, and I select top. Now what is it I do next? It's a long time since I've used this. Extrude. No. Scale. Right, now I do extrude, and yeah, that's it. This is what we're talking about. You can see it's got a solid bottom, has a thickness wall, and it has this hollowed out there. Now, what is the surface area once I've allocated sizes? How are we going to deal with that? With something like this, a complex shape, you break it down into little bits that are easier to work out, and this is what we're going to do. I'm using colour to identify the different parts. We have the outer wall there, and we have a fill-in at the bottom. Now I'm going to do that a different colour. Let's do that green, shall I? This will be a circle. This will be like a rectangle. You'll see in a moment. Now we have the ring at the top here. I'm going to make that. I don't know how well this will show up. Purple. There's the ring. Now what we're doing in fact, it's almost as though we've got a saw and we've cut it like that through the center, and we are looking at it in that direction there. So that cut there would be this line, that ring there would be this, the ring there would be this, the base would be this here. The inner wall, the red, would be down like this, and I'll do white for that bit there. Now my intention is, although it's not visually the case, this is all the same thickness, and I'm going to make it, say, what should we go for? There. Let's go for 5 millimeters. So that thickness is 5, that is 5, and that is 5. Let's make the overall size here, the outside diameter. What shall we go for? Let's go for 30, shall we? That's not very clear, is it? Let's do that. A bit better. That's better. 30. Whatever units we're measuring, you know, it could be millimeters, centimeters, meters, yards, it doesn't matter. It's 30. That's 5. So that will be 5. That will be 5. This will be, this diameter here would be 30 minus that thickness and that thickness. But what they would tend to do is they would miss things out such that it forces you to work out what they are. And what height shall we give this? Let's give this a height of 40. Now we need to work out that one, and we can do that by difference. We've given that, yeah, we've got everything there that we need. Okay, let's break it down into parts, shall we? Into manageable parts. Let's look at this vertical here, this wall, this blue wall. If you were to cut it and open it out, it would be the shape. It would be a rectangle. If you were, all not to scale, open out the red wall, this bit here, that would also be a rectangle. See, we're starting to break it down into parts. We can add sizes in a minute. So that's done the red, it's done the blue. Now let's do the white. All not to scale. The white will be a circle in here. So we have, it's going to be not very well drawn. I'll do my best. That is this. Now we got the green. See, we're not thinking about sizes at the moment, we're just thinking about shapes. Meant to be circle, meant to be a circle. There we are, we've broken it down into its parts. Now we need to work out the sizes. Let's start with the blue here. We know that the height, let me go to white, the height is 40. Right? Yeah, height is 40. Now the distance round is the circumference of a circle. The distance round, circumference of a circle. The diameter is 30. Now circumference is pi times d. Or if you like, that is twice the radius, so it would be 2 pi r. Right, so the d in this case is 30. This one here, 30. So it is, the area is 40 times the circumference of the circle, which is, and I'm going to put that in a bracket, pi times the diameter, and the diameter is 30. Right, that's the distance from there to there is 30. So it's pi times 30. Not doing any calculations at the moment, we're just working out what we need. This one here, now it is not 40 because you can see you've got a thickness of material there. So it is 40 minus that thickness, and that thickness is 5. So the distance from there to there is 40 minus 5, which is 35. Times. Now again, we use pi times the diameter for the circumference. What is the distance, the diameter in here? 5, 5, 30 overall. 30 minus 5 minus 5 is 30 minus 10. So that distance there is 20. So we have pi times 20. Let me put that in there. Now that's handy because that now gives us the diameter of this one here. Now the area, that's for the circumference. Right? The area is pi r squared, where r is the radius, which is half the diameter. So this is our r here. It is pi r squared. Now in this case, r is half of 20, so that is 10. So we have pi times the radius squared, 10 squared is the area. This one again has the same formulae from the center. The outside is r, that's the green, and that is 30. R is half of 30, so r is 15. And the area of that one is pi r squared. R is 15 squared. Now we can work these out. We don't have to multiply these in order. We can multiply 40 by 30, you know, in the same way that 2 times 4 gives exactly the same answer as 4 times 2. We can move things around. So if we have 2 times 3 times 4, we can go 2 times 4 times 3. It would give us the same answer. Well, I'm going to use that idea now with what we've got here. And get rid of all that line. Inasmuch as I'm going to say 40 times 30. Well, look, 4 times 3 is 12. 10 times 10 is 100. And it's multiplied by pi. That is the area for that part. This one here, 2 times 35 is 60, is 70 times 10 is 700. Not sure? Let's have a look. 35 times 20 equals 700. There you are, you see. Right. This one here, 10 squared is 100, so it's 100 pi. Notice I don't convert these to decimals at this point here. As soon as you convert them to decimals, you introduce an error. This one here, 15 squared, no, 15 squared, so let's clear that. 15 squared, 225. Don't forget the pi. Now we add them all up. 0, 0, 0, 5. All times pi. 0, 0, 0, 2. 2, 7 is 9. 10, 11, 12. So the total area is 1, 2, 2, 5 times pi units squared. That is an exact value. Convert that into decimals and introduce an error. Pi as a decimal, this will only display some of the numbers. The digits never stop. Look, let's do shift pi equals, convert a decimal, there you are, 3.1416 is a standard one that some people use. 141, round it off, cut off point here. Because the 9 is greater than 5, we round up the 5, so it goes 1416. You can get fraction equivalents. Sometimes you see 22/7. I've used that in the past when I was at school. They tend not to use it so much now. That is an estimate of pi. It is not the value of pi. Okay, so you can see that we broke it down into different parts and worked out each part, then added them together. We worked out or we separated out that wall there, the blue, into its shape. It opens into a rectangle. The red, which again opens up into a rectangle. We then, oh, I haven't done the ring. I've forgotten the ring. So this is not the complete answer. Oh dear, I forgot the ring. I forgot the ring. Let me lift this up. Oh, come on, up you come. Okay, the ring. It consists, this purple bit. Let's change the colour to match. We have, very badly drawn, an outer. That's not working. Why is that not working? An outer and an inner. Oh, that's awful. And what we're interested in is this part, the ring. We know that the outside diameter is 30. And this bit there to that bit there is 30. So let's put that there. And we know that the inner part here is 20. Work out as if it was all just one circle. Work out that circle, subtract one from the other, and you get the ring. So you have the whole, remove the bit. The complete thing, remove the bit in the middle. Now the area is pi r squared. That's the diameter. R is half the diameter, which is 15. This one here, R is half the diameter, which is 10. So what we have, the whole thing, pi r squared, remember it's pi r squared, the whole thing is equal to pi times r is 15 squared, and this one here again is pi, different r this time, equals pi half of that, which is 10 times 10 squared. Notice this is the same set of numbers as that. So we know straight away that that one there gives us 225 pi. 10 squared is 100, so that gives me 100 pi. Okay, now we do the difference when the pen works. 100 from that leaves 125. Don't forget the pi. Oh, when you have a value that doesn't change, it's called a constant. So that is the constant pi. And what we've got to do is add these two together. So we end up with 1,225 pi plus this one here, 125 pi. Add them together because that's a subtraction, that's an add. Now of course this just becomes, we're counting pies, counting pies here. 5 plus 5 is 10, carry the 1. 2 plus 2 is 4, plus the 1 is 5. 2 plus 1 is 3, that's not very good, 3. And 1 plus nothing is 1. So the answer is 1350 times pi. Now let's have a look at this, and it's on the wrong screen. Okay, now if you want to convert that to decimals, we can go for 3 decimal places. We have 1350 times, now the pi in here, there's the pi, is brown, so we do the brown, the shift to get the pi. We got that. Now that gives me that. I need to convert that to decimal, and here we go, 4241. So that's equal 4241. There's a decimal point, and we have 15. I said 3 places, so there's your cutoff between the zeros. To the right of the cutoff is less than 5, so we don't round up that 0 there, so it's 150, 150 to 3 decimal places. Now if you say 3 decimal places, there have to be 3 digits, 1, 2, 3. Even if it's nothing, you know, if it's 0, it has to be there. So, and that is units squared. Don't forget. No, don't write it like that. Let's get rid of that. Nearly made a mistake. So it is 4,241.15 square units, and that is to 3 decimal places. You must declare that.